In this stage, Dexter tries to find actions for persuading benevolent humans to move the desired object closer, using its head motions alone. After interactions with 10 different subjects, Dexter was able to learn a simple program that uses alternating gazes as a means of acquiring assistance from the human subject. The resulting policy is as shown in this diagram. This simple gaze gesture, although not yet ideal, performed better than random for soliciting the desired response from the human. Offline analysis of the recorded videos reveals interesting insights regarding the causes of the failed attempts. Number 1. Gaze is imprecise as eidetic pointers because the motion is subtle, and therefore sometimes the direction can be ambiguous. Number 2. Even though the user has determined which object the robot wants, it can be still confusing as to where the object should be placed. 40% of the subjects took several tries to place the object within the reachable region of the robot. Sometimes these confusions can accumulate to frustration such that the subject may decide not to help at all. Even more surprisingly, for this stage, novice subjects have more successful rounds of interaction than supposedly more knowledgeable computer science students. Since this is such a simple scenario, that overanalyzing tends to cause more confusion than if the user simply acted out on instinct. In this video, the top left subject is one of the more knowledgeable computer science students. Here, compared with novice subjects, he waited longer before taking actions. This led to more failure attempts from the robot during the initial rounds of interaction. During the second stage, Dexter was also allowed to explore using its arms throughout its interaction with the subjects. This time, as a natural outcome of exploring learned manipulation behavior, the robot found the failed attempt to grasp the object as a more effective alternative for the gaze gesture. This is because the new pointing gesture is both more conspicuous and causes less ambiguity regarding where the object needs to be placed. In fact, even the subject who did not attend to Dexter at all in the previous stage responded almost immediately in the first round. However, the new pointing gesture introduces a new problem. When the subject hands the object to the outstretched hand, sometimes the object can be blocked by the hand, and as a result, the arm retracts and thus confuses the subject, thinking the robot does not want the object. Although this did not occur often enough to prevent the robot from learning the pointing gesture, it is conceivable that if smaller objects are used, more unsuccessful attempts would arise. This problem can be resolved if the robot develops the understanding of occlusion as part of its manipulation skill. Or it is also possible for the robot to improve upon the existing gesture by incorporating other manipulation behavior, such as pick and place, when it becomes available. Experiments in this study has demonstrated the feasibility of the proposed approach and the soundness of the learning framework. By using the same framework for acquiring manual skills, Dexter was able to learn the utility of the manipulation behavior as expressive gestures through interactions with humans, thus providing grounding to the gestures learned. Computation-wise, this approach is efficient since it does not require the robot to learn from scratch. It is also adaptive by design while minimizing the need for relearning. For instance, although the robot started out learning to point with one arm, it can immediately generalize to point with either arms as the situations require. More interestingly, as soon as the robot makes the connection between pointing and the reach-grab action, the robot's gesture repertoire is automatically extended with the ability to size hint, as the reach-grab action contains different contingencies for handling objects of different sizes. On the issue of incremental learning or lifelong learning, from the results of this study, it is conceivable that as more manipulation skills become available, the robot can use the same mechanism to explore and negotiate more effective gesture with the human user.